the night sky is full of enchantments. The Hubble telescope allows us to look very far into space and delve deep into past time. If we pay attention to detail, we will see that the only tool that allows this journey of ours is the cosmic radiation, appropriately called background. We are talking about the light generated by stars and distant galaxies, as well as the light that planets reflect when illuminated by the sun. It spreads out on Earth after a long journey through space. This comes at a price. It is that light behaves as if it were the messenger of space, taking away from it the ability to communicate any galactic events directly to us. So much so that if at this moment a star exploded in a supernova, we would only know it after thousands or millions of years. There would be no cosmic background radiation available in the present, as long as the arrow of time continued to point to the future, for the future has not yet arrived. Another illusion, supported by light, is that of time in the past. This is due to the very common practice of trying to measure time and space with the aid of the limited speed of light. Once time and space are removed from this equation, we are left with only the messenger, represented by cosmic radiation. It has its own characteristics, such as performing a periodic movement, known as simple harmonic. It is well represented by a block attached to a spring, which, in turn, has its other end at a fixed point. When the spring before at rest is stretched, pulling the block, there is the first phase of the simple harmonic motion. The other phase arises when the block and spring are pushed against the fixed end. This behavior would apply to a rubber band. Astronomers often use this model to also describe the behavior of space, showing that space and light would form a single whole, a continuum, which stretches or contracts through infinity. In fact, although it may go unnoticed, the illusion of the stretching or contraction of space is due only to cosmic radiation and its simple harmonic movement. As we saw earlier, space depends on this messenger to impress our telescopes, which, in the case of observable stars, occurs with an immense delay. The simple harmonic movement of light is related to the circular and uniform motion. So, when light was used to describe space, everything in our observable universe should rotate in a uniform circular motion. The movement of planets around the Sun is also periodic. When we replay the motion from Earth to the Sun, it appears to move over the ecliptic, forming a perfect circle. In fact, our star is immobile relative to Earth, although it follows the movement of the Milky Way. The circular motion has constant speed and acceleration, which is at odds with the real orbit of the planets, which is elliptical. Planets accelerate when approaching the Sun, and do the opposite when moving away. It is seen that sunlight, acting as a messenger from space, does not allow us to directly see the elliptical motion being transmitted from Earth to the star. This also happens with distant galaxies. Its stars revolve around the galactic core in apparent uniform circular motion. Distant spiral galaxies, carefully watched by astronomers, suggest that their stars follow the same type of motion, which is shown in a documentary in the Discovery Channel's The Universe. Carnegie Institution astronomer V. Rubin, observing the movement of stars in a distant spiral galaxy, made a remarkable observation. Like particles that fall in a whirlpool, the stars in its outer part should move more slowly than those in the center. However, they moved as quickly as the more central ones. Physicists concluded that there must be, in the case of spiral galaxies, a gravitational pull that would require much more matter out there than we can see. So, they called it dark matter. Note that interference from the isolated observer, which gives meaning to the image of galaxies captured by our telescopes, is not taken into account. It's that we believe that what we see out there is the raw reality itself, and not the result of a late projection of information collected by our brain. Even to observe a particle at the subatomic level, there is a limitation imposed by time. We do not see that particle directly, as we observe it through the light it reflects. The question of circular motion can only be addressed in theory. Kepler was one of the few who managed to overcome this impasse by drawing up his planetary laws. This apparent circular motion of planets and stars has kept humanity for many centuries trapped in the illusion that the Earth would occupy a centralized position in the universe. It's just that all the stars in the night sky seem to rotate from east to west with constant speed and acceleration. Let's suggest a solution to the problem that should be carefully evaluated, as no one owns the truth. The light we receive from distant stars could not be observed directly due to its two-dimensional nature. This is only possible after the light undergoes a process of condensation or packing, known as quantization. All recordable forms of energy are quantized. The main feature of quantizing the light is that it doesn't take time. So, if a planet's orbit were indirectly described using sunlight, it would shape actual elliptical motion, transmitting it into apparent circular motion. In so doing, the light would contract time to subliminal levels, virtually flattening the sun's future light cone. The conversion from elliptical to circular motion, by packing the light, would involve the observer's point of view. It would generate the necessary torque to put the previously static universe in relative and continuous motion. Everything in the universe would revolve around a center of mass. The continuity of the movement of galaxies would result from the thesis that, to sustain the uncertainty of their positions in space, the contraction of time would have to remain suspended at infinity. At least, when it comes to our point of view. Our temporal memory would be supported by the uncertainty of the position or speed of light sources. As we would be talking about uncertainty when driving us to circular motion, quantization would not allow us to scale the time before the scattering of light from the distant source, or the time that would determine the depth of the future light cone of events. Thus, it would not be possible to measure directly the delay that the light of a star would undergo when traveling the distance to us. The leveling out of the energetic extremes of light, by quantizing it at the subatomic level, would force the observable universe out there to show a tendency to flatten out at the limits of our event horizon. It would also cause visible matter to tend towards its state of rest, a situation that could never be achieved. That is, the contraction of time could not be total, aiming to preserve our memory. It is seen that the contraction of time would happen at the subatomic level of the particles that make up our brain, while, in the macrostructure, this time seems to be continuously dilated. This would explain the apparent reversal in the direction of the arrow of time in our position on Earth, as it seems to continually point to our past. This apparent inversion would result from the principle of excluding direct access to what would be in our future. As an example, we can mention the 75 years that the light of Beta Andromeda would use to travel through the space that separates us, until the exact moment in which its light spread along with us. From astronomer Rubin's observation that the stars in the outermost part of a spiral galaxy moved as fast as the most central ones, physicists concluded that the gravitational pull necessary to equalize the speeds would require much more matter than the ones that we can see directly. As it has not been possible to identify this matter or the energy related to it to date, physicists are forced to contradict the very premise that there is only what can be measured directly. Looking closely at the quantization process of light, one might think that no additional matter would be needed to explain the gravitational pull. It would be enough for space to act on this total dark matter, changing its density. The concept of dark matter arises when it is verified that the packaging of light, in the form of a photon, does not require measurable time. No time, no movement or energy. This photon, once scattered, would act as a space messenger, forcing us to live with events outside their own time. That is, we see stars looking as they would have taken on in our own past. Quantization bears a striking resemblance to the concept of a star's future cone of light, as both do not require measurable time. Thus, the uncertainty of the position of distant light sources would be linked to the behavior of the messenger without being able to directly assess the action of space on the masses. For example, by changing its curvature, space would influence the passage of time within the event's future light cone. This would happen in a veiled way, as the future has not happened yet. The reason for this would be the tendency to level the energy extremes of light due to the necessary phase of its quantization. Without it, we would not be able to perceive light energy. Even if the motion of stars in a distant galaxy were elliptical, quantization would force space to seemingly flatten and merge with light itself, making it virtually flat to observation. By contracting time in the process, the messenger would assume the command that should belong to the center, forcing us to live with a circular and uniform motion. What would be regrettable, due to the confusion that circular motion causes in our points of view, would justify the idea that our universe, in principle static, could have entered into relative and continuous motion. In the observable universe, there is no absolute motion. This relative motion would not depend directly on the masses, but on the independent capacity of space to generate inertia. It would act directly on the masses, influencing their density at the future point. If the density increased, the future light cone at the event would deepen and retain more time inside. If the density decreased, the opposite would occur, expanding time. None of this would be directly accessible after the scattering of light in our past. The most classic example is that of our Sun, which always maintains the same volume and the same mass as it moves over the ecliptic in a uniform circular motion.